Right, welcome to this YouTube video. On this video, we're going to be looking at line integrals. Now, line integrals are of two forms. We have the one that has to do with the straight line, which has the notation, and then the one that has to do with the curve. So we'll be looking at questions on that straight line, and then we'll be looking at questions on that curve. So this question on our screen now is let f equal to 1 minus x, comma 1 minus y squared. Determine the line integral f dr along a straight line from 0, 0 to 1, 1. Now, this information has been given. So basically, what I first like you to understand is what we are actually asked to do. Right? Sorry, let me change. Right? Change to black. Right. So now what are we asked to do? We are asked to find the integral from a to b of f dr. This is what they asked us to find now. So now for integrals like this, where we have to do a straight line and they give us notation, it is standard that your limit goes from 0 to 1. This is the standard limit. So that means a 0 is your a and then 1 is your b. So now I've gotten that out of the way. Now our f was already given, right? To be 1 minus x, comma 1 minus y squared. Now our dr is what we need to find. And basically our dr is the x over dt, comma dy over dt, right? Then dt. This is basically what our dr is. So first we have to find the x dt and dy dt, so we can now use our dot product and then we can solve, integrate and all that. So how do we find the x dt? First we have to first find what x is in relation to t and what y is in relation to t. Basically we are going to be making two parametric equations, one for x and one for y. Now we're going to say x and y, right? This is now first before we do this, now these points that we're being given 0, 0, right? This notation is 1, 1. Now I want you to understand that this is x1, y1, this is y x2, and this is y2. Now that we have that, get our parametric equation is very simple. We have x1 plus t multiplied by x2 minus x1. Then we have y1 plus t multiplied by y2 minus y1. Very, very simple stuff. So now that we know this, we can just go ahead, put our values and so x is equal to x1 which is 0 plus t x2 which is 1 minus x1 which is 0. Then we have y is equal to 0 plus t, then we have 1 minus 0. Same stuff. So we have x is equal to t and y is equal to t. Now that we have this, we can easily find the x dt, right? We can find the x dt by integrating t respect to x, which is equal to 1, and we can find the y dt, which is also equal to 1. Now that we have this, we can write our dr as 1, 1 dt, right? We have this. So now we can find the dot product of f dr, which is going to be 1 minus x, 1 minus y squared, then multiplied by 1, 1 dt, and here we're going to have now this dot product. So the first term here, 1 minus x, multiply the first term here, and then the second term here multiply the second term here. That's all. 1 minus x times 1 will give us 1 minus x, then 1 minus y squared times 1 will give us 1 minus y squared, and we have our dt. So now we take the integral, right? Remember, this is our FDR now, right? So we can replace it here, right? I remember our limits, our standard limit is 0 to 1. We have 0 to 1, and then we have 1 minus x, right? So now that we are putting it into the integral, we can remove this comma and just put plus 1 minus y squared, then we have dt. Now remember that your x is t and your y is t, so we can replace x and y in this equation here. So we have this, then we have 1, 0, so we have 1 minus t plus 1 minus t squared dt, right? Right, so for me to finish off the solution on this other side of the board, so yeah, let me write this. So we have the integral from 0 to 1, 1 minus t. Okay, we have 1 minus 1 plus 1 here is going to give us 2. So let me just change this to 2. 2 plus, so we have minus, right, this supposed to be minus t. Right, sorry. Alright, so we have 2 minus t squared dt, and then we just take our integral. So we have now be 2t minus t squared over 2 minus t cubed over 3 for our limit from 0 to 1. Then we just impute our limit. So we have 2 into bracket 1 minus 1 squared over 2 minus 1 cubed over 3 Then we have this. Right, so you can pause the video to try out question two. Right, so let's do this. Now we have g is equal to x squared, then minus 2 comma z, right? So now for this one, now we have x and z, so that is our dr. Our dr is going to be equal to dx over dt, comma dz over dt, then we have dt. Sorry, right? So it's going to be this. Now, basically, we're actually going to follow the same exact process. Now we have our point 0, 1, right, to 1, 1. Right, don't forget our x is equal to x1 plus t multiplied by x2 minus x1, and our y is equal to y1 plus t multiplied by y2 minus y1. Very, very simple. So x is equal to 0 plus t, 1 minus 0, right? And then our y is equal to 0, the r is equal to 1, that's 1, that's 0. We have 1 plus t multiplied by 1 minus 1, right? So then our x is equal to 0 plus t, which is equal to t, and our y is equal to 1 plus 0, which is equal to 1. We have this, and then we'll find our dx dt. So this supposed to be z, right? But it does not really matter. But let me just change. Let me change to z. Let me change it to z. I hope it does not really matter as long as so Z2, Z1, here we put Z and here we put Z. Right. So now the X dt is going to be 1 and then the Z dt is going to be equal to 0 because when you differentiate 1, you get 0. So we have this, right? Let me just clean this. Let me rub this off. So write it up. So now we're gotten our dx dt to be 1 and our dz dt to be 0. So I'm just going to write it up so we have enough space to solve the actual question. Right. Now we're getting our dr to be equal to 1 and 0 dt from our calculation. So don't forget our x was equal to t and our y was equal to 1. Right? This is because it's still going to be needed at the end of the day. So now we're going to find our g dr, the dot product of g dr. So we have x squared minus 2, comma z, but dot product 1, comma 0 dt. Remember the first one multiplies the first one, second one multiplies the second one. So our g dr equal to just x squared minus 2 because z times 0 will give us 0. Then we have the t. Then we take GDR from A to B. Remember our limits, our standard limit from 0 to 1. Then GDR is x squared minus 2. Then we have the t. I remember that your x is t, right? So we have 0, 1. Then we have t squared minus 2 dt. So we have our integral, that's t cubed over 3 minus 2t from 0 to 1. Then we put our limit. So we have 1 cube over 3 minus 2 times 1. Then everything here minus what we have in the other bracket will automatically become 0 because of the 0 that we have substituted. Right? So we have 1 over 3 minus 2 over 1, which will in turn give us 1 minus 6, which is equal to minus 5 over 3. So very, very simple stuff. So that's all for line integral for straight lines, right? So now let's deal with one question on that curve. So for a curve, this question says a curve C is given parametrically by x equal to 5t, y is equal to 12t, where t runs from 0 to 3. Evaluate the line integral of x squared over y. So now basically what they are asking us to do is the line integral from C by curve C of x squared over y ds. This is basically what they're asking us to do. So now we have this out of the way. Now the general formula is something like this, right? Fx of y multiplied by ds. Now the s is equal to the square root of the x over the t squared plus the y over the t squared then dt, right? This is basically what our s ds is. So we can rewrite this formula as c equals to fxy multiplied by the square root of the x over the t squared plus the y over the t squared times dt. So this is what we're looking out for, right? So just like that one, we also need to find dx dt and dy dt if we have to solve this question at all. So now, basically, what this tells us is that our f of x of y is equal to x squared over y. So the only thing left is for us to find the x dt and the y dt. And now they've really given us the parametric equation to be 5t and our y to be equal to 12t. We can easily find the x dt to be equal to 5 and then the y dt to be equal to 12. And then we just plug in our values and stuff. Now, they gave us the limits from 0 to 3. They gave us from 0 to 3. We have from 0 to 3, then our x squared over y multiplied by the square root of the x dt squared. The x dt is 5, then 4 squared times 12 squared, then we have times dt. Remember, we have x squared and y here, and basically we do not want to have more than one variable. So we can change x to t and also change y to t, right? Because x is 5t and y is 12. So we can replace that. We have 3 from 0 to 3. Then we have 5t squared over 12t multiplied by 25 plus 144 dt. So we have that. Now we take our integral from 0 to 3. 5t squared will be 25t squared over 12t. And then we have multiplied by root 169 dt. So t here will cancel t here. So basically we have 0 to 3. And then we have 25t over 12 multiplied by 13 because root 169 is 13. So we have this. Right? So now we can bring out um, our constants, right? Basically 25 times 13 over 12. We can bring that out. 25 times 13 should be 325 over 12. Then the integral from 0 to 3 of t dt. Then that's 325 over 12. Then we have t squared over 2 from 0 to 3. Now, when you put 0, you already know you're going to get 0. So let's just put 3. So 325 over 12. Then we have 3 squared, which is 9. So 9 over 2. So we have this, and then our final answer will be 975 over 8. So these are our final answers. So very, very simple stuff. So regardless whether they give you a curve or they give you a straight line, so just make sure you look at the question. You see a curve, you see a straight line. You see a curve, you're applying this formula f of x, y times the s, where the s is the square root of the x over dt squared plus the y over dt squared dt. But if they give you for a line, you get your parametric equations, and then you take the dot product of FDR, and then you integrate and you get your answer. Remember, the standard limit is from 0 to 1.